I'd like to talk briefly today regarding trigonometric functions. Um, the idea here is to essentially solve for the function as you would an algebraic equation by chance. And the idea here is to find solutions over a particular interval. So when we do set these trigonometric equations to zero, we will actually usually get radian measures which actually fall somewhere in the unit circle. And we may not always be looking for solutions over fixed intervals. For instance, the interval can change from, in this case, 0 to 2 pi to negative pi over 2 to 0. So it really depends. But for this example here, we can approach this in a couple ways, right? This is, after all, an equation, so isolating things that are not like each other is probably a good approach. You could take the 4 to the you could take 4 to the other side by making it negative, and then perhaps using the square root property to work it out that way. Or you could, in fact, use the difference of squares. Unfortunately, I put a plus here, but it is in fact a minus. So that makes it apparent you can use the difference of squares. And I guess for purposes of simplicity, we could just say that uh, cosecant squared x equals positive 4. And if we take the under root, the square root of both sides, we want to ensure that we add a plus or minus here, principal root after all. And the cosecant x equals plus or minus 2. And of course, this is something that we're not particularly familiar with, although it's possible. Um, it's perhaps more difficult to work with cosecant x. Instead, if we reflect cosecant x to be something that we know, such as sine, cosine, tangent, then it would be easier to work with. So recall that the cosecant of theta, or cosecant x in this case, is 1 over the sine theta. And we can then rewrite this as being 1 over sine x equals plus or minus 2. This is, of course, an equivalent form. And then I suppose we could solve for sine theta, and in the process of which we can have 1 equals plus or minus 2 sine theta, or x. And dividing by plus or minus 2 actually tells us that the sine of x equals plus or minus 1 over 2. And when you arrive at an equality like this, an equation that you can't do anything else with, you're actually looking for solutions where that equation is true or where it's satisfied. So in this case, we're looking for where the sine of x equals 1 over 2. Now, in doing so, if we evaluate the unit circle for a bit, we recognize that on a unit circle, the sine of x is 1 over 2 at, so we want to consider two solutions. The first is the positive case, and first is the negative case. So the positive case, and I'll write a positive here, the positive case is where the sine of theta equals 1 over 2. Now, the sine of theta characteristically is positive in quadrants number 1 and number 2. So there will be solutions basically on these quadrants that satisfy the fact that sine of x is equal to 1 over 2. In quadrant number 1, we know that pi over 6 equals 30 degrees, and 30 degrees is equal to, if we talk about the sine of x is equal to 1 over 2. And so we could say that the cosine here is under root 3 over 2, and the sine is, in fact, 1 over 2. So pi over 6 is actually one of our two solutions. So if we write our solutions down here, or actually let me just make it red. So pi over 6 is one of our solutions. Another solution here would, of course, be in the second quadrant. Now, we want to recognize that this is an angle relative to the x-axis. And to find the accurate multiple of pi over 6 in quadrant number 2 would just be a fact of taking pi and subtracting it, or actually taking pi over 6 and subtracting it from pi, right? Because this is pi, and if we subtract pi over 6 that way, we should get the accurate multiple of pi over 6. Insofar as doing so, we get 6 pi minus pi is equal to 5 pi over 6. So this is so these would be our two solutions here. Pi over 6 is our original solution for the first quadrant, and then of course subtracting pi over 6 from pi, we essentially arrive at 5 pi over 6. These are our two solutions. Now the positive case, of course, we had this only addressed the positive case. Now that we're coming to address the negative case, I'll put a negative here. We want to understand that's a terrible circle, but we want to sort of understand that the sign is negative rather in quadrants number 4 and number 3. So instead of having solutions in quadrants number 1 and 2, instead we'll have solutions in quadrant number 2 and 3, or actually 3 and 4. So again, these would just be multiples of pi over 6 because, of course, if we had, if sine is here, if it's 1 over 2, then reflecting that over onto the y over the x-axis would give us the same angle for sine, that is. So we do this by, so first let's work with the third quadrant here, and instead of subtracting from pi as we did up here to get into the second quadrant, why not add to pi in order to get to the third quadrant? So we add pi over 6, and we arrive 6, and then 6 pi plus pi, get 7 pi over 6. So that's another solution here for quadrant number 3, and for quadrant number 2, it is essentially the same process, and it's the same process because we want to recognize that here we have 2 pi and 2 pi minus, because we're trying to get into the fourth quadrant. 2 pi minus pi over 6 in this case is just going to be 6, and then 12 pi and minus pi, so that's just 11 pi over 6, and that's essentially our assessment there. So we have these solutions, right? We have one solution, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. These are all solutions, and you'll notice that all angles are actually in the range of 0 to 2 pi. But what you'll not notice is that, perhaps not as obviously, that not all of these answers, in fact, none of them, are on this particular interval. So let's investigate this for a bit. While these would all be solutions on the interval 0 to 2 pi, they would not all be solutions on the interval negative pi over 2 to 0. In other words, if you have negative pi over 2 to 0, we would not have solutions. These would not be solutions from negative 90 to 0, because of course none of these angles are negative, right? So we want to first figure out this particular interval and where it sort of graphically resides. And going this way, we know, is going positive, and going this way is actually going negative. So counterclockwise is actually going positive, and actually going clockwise would be negative, and going counterclockwise would be positive. So if we started here at 0 radians, which is of course the same thing as 2 pi, it depends on which way you're going around, but if we travel 90 degrees this way, then we would actually be traveling negative 90 degrees. And so let's look at this graphically. We had let's see here. So we had we had one solution, which was 5 pi over 6 is one solution, right? That was one solution, and then we had 5 pi over 6, so that was sort of another solution in this quadrant here, and then we had 7 pi over 6, and we had 11 pi over 6. So this angle, 11 pi over 6, actually falls between this particular, it's in this quadrant, but it's not on the interval, because 11 pi over 6 is actually equal to 330 degrees. And to say that 11 pi over 6 lies on this interval would be the same thing as saying that 330 degrees is sort of sandwiched between negative 90 and 0, which is just not true. This doesn't make any sense. And so we're not actually looking for, we're not judging the fact that 11 pi over 6 is graphically on this interval. We're trying to judge whether it numerically lies on this interval, which it doesn't. And so the idea here is to find an angle which is coterminal to 11 pi over 6. And that is also on this particular interval from negative 90 to 0. And the idea here is that if we were at this point and we subtracted 2 pi, or 1 revolution, we would essentially go just like this and end up right back here. And if that's on this interval, then that is a solution. So the idea here is to take 11 pi over 6, right? 11 pi over 6, and subtract 2 pi from it, and that would give us 6, and then we have 11 pi here. We have 6, and then we have 11 pi minus 12 pi, which is equal to negative pi over 6. So negative pi over 6, so we have negative pi over 6 and 11 pi over 6. Now only one of these are solutions because negative pi over 6 is just negative 30 degrees. And while this is not true, to say that negative 90 is essentially sandwiched between this interval here is a fair assessment. So this is a solution, while 11 pi over 6 is not. But they are coterminal angles. Their terminal sides coexist, which is why they're called coterminal angles. And so if we're looking at this interval here from 0 to 2 pi, then of course, to say that these four were solutions, this guy here, this guy here, this guy here, and this guy here, that's a safe assessment. But if we're talking about from negative pi over 2 to 0, then this would be our solution, negative pi over 6. And let's sort of take this assessment further with perhaps another problem here. Of course, evaluated on both intervals. We have cosine minus sine x equals 0. And the idea here is to, again, of course, solve in such a way that you're left with an equation that you can look for solutions for on the unit circle. And that, of course, is simplified down to its simplest form. So here, I mean, it jumps out as obvious to take cosine x and equate it to sine of x, and now you are now looking for where such an occasion is apparent on the unit circle. So again, if you look at the unit circle, the cosine of x. So if we have the unit circle here, the cosine of x is equal to the sine of x at pi over 4. Right? Because we know characteristically that pi over 4, the cosine at pi over 4 is 2 under root 2, and the sine of pi over 4 is under root 2 over 2. Now this is true for this particular quadrant. So if we're evaluating on the interval 0 to 2 pi, then pi over 4 would in fact be a solution. But this is also true in one other quadrant. It was true in quadrant number 1 because the sign of cosine and sine were both the same. They're both positive, and that's why, of course, they're similar. Now, if we reflect pi over 4 over the x-axis here, we would have a positive cosine. We know the cosine denotes the x value, so. And the x value in this quadrant is positive given the quadrantal angle here. And the sign, however, would be negative because the sign here is in fact negative. So we'd have negative 2, negative under root 2 over 2. And if we were to reflect this over this axis here, we would be pi over 4 up from the x-axis, and here the cosine would be negative and the sine would be positive. So they're not. So the cosine doesn't equals the sine in terms of magnitude, but not in terms of its sign. That's only apparent in the first quadrant. Now there's one other quadrant in which such an anomaly is true. The fourth quadrant actually tells us that the x value here, in other words, the cosine, is negative, as is the y value. So the y value is also negative in this particular quadrant. So here, at an angle of pi over 4, which in fact would be, let's see, so we would have pi here, and then if we were to add pi over 4, and this of course is a way to mess with reference angles to get the accurate multiple. But we would have 5 pi over 4. So at 5 pi over 4, the cosine is it's negative under root 2 over 2, and the sine is also negative. So the cosine also equals the sine in this particular case. So if we're evaluating on the interval from 0 to 2 pi, then these solutions, that is of course pi over 4 and 5 pi over 4, these solutions stand true. But if we revisit sort of the caveat that we had here, the caveat interval, negative pi over 2 to 0, does this stand true? So is pi over 4, so we have negative pi over 2, which is negative 90, and we have our interval 0. So negative 90 to 0. So does do any of the solutions that we had satisfy this interval? The answer is no. Pi over 4 is positive 45, and to say that positive 45 is sandwiched between this interval is not. It's just not true. And the same thing with 5 pi over 4. I mean, if we take that's a positive angle. These are positive angles, and none of them are negative. And so neither pi over 4 nor 5 pi over 4 are on this particular interval, which means there are no solutions. But then, of course, we're eager to think, what if there are solutions, but what if the angle is coterminal by chance? Well, the answer, well, that would be an ineffective judgment, because the interval that we're currently concerned about is from 0 to negative 90, right? As we were over here. And that is just not true, because there are no angles, there are no solutions on this particular quadrant. Our first solution was pi over 4, which was on this quadrant, and our second solution was 5 pi over 4, which was on this quadrant. There were no solutions on this quadrant because the cosine and the sine were actually different in terms of their sign. And so we could not, and so our final judgment would be to then assume that there would be no angles on this particular, no solutions on this particular quadrant. So hopefully that helps in terms of solving trigonometric functions, and a graphical interpretation is very much needed to get through these questions.